Hey everybody, Mr. Judson here. So we've done everything we have to do, nothing new to learn, although we do need to go back and cover just one thing. We've learned how to take derivatives with natural logs and e to the u, but we have to go back and do things like implicit differentiation, how do you find the equation of a tangent line, what's the slope of the tangent line, things like that, relative maximums and minimums. And so that's really what we want to do for today, is to just cover those ideas. So let's see, right here I've got an equation. It would be difficult to get y by itself. So when we find the derivative, we want to do it implicitly. I think the nice thing is that I saw in the Central Washington exam that when you have to find the derivative implicitly, they actually tell you that. They'll say, find the derivative implicitly. So that's kind of good to know that we don't have to remember exactly when we need to do that. But that's how you know, is when it's difficult to get y by itself. All right? You guys go ahead and try this. All right, so when I take the derivative of a natural log, that means I want to do u prime over u. So I'm going to have this in the denominator, and then the derivative of that in the numerator. Now, because two things are being multiplied, that means I have to use the product rule. Right? So I'll take the derivative of the first piece, which is 1, times the second, that's y, and I just took the derivative of an x variable, plus, leave the first the way it is, take the derivative of this, derivative of y is 1, and I just took the derivative of y. See, the only time you put dx's and dy's down is when you're actually doing the derivative of that variable. When I just write it in the denominator, I'm not doing a derivative at that point, so there's no point in writing it. All right, derivative of that will be 5, and I just took the derivative of x, and the derivative of that will be 0. So now, to get rid of the fraction, I want to think just like we always have. Multiply through by the least common denominator, which that's the only denominator. So I want to multiply this whole thing by xy, I want to multiply this by xy, and I want to multiply this by xy. And so when I do that, these cancel. So I'm left with y dx plus x dy. When I multiply here, I just get 5xy dx, and anything times 0 is just 0. And so now we put all of our dy's on one side, dx is on the other. I think I'll just leave the dy term there. So I've got x dy. I'm going to move both of these terms to the other side, so they both have to become negative. And we're going to factor a dx out, so I'll have a negative y minus 5xy. Mr. Leach's dog. And so now to get dy over dx, I'll bring this over and divide. And then I'll take the x over here and divide. So I get a negative y minus 5xy over x. There's my derivative. And remember, if somebody had all the signs opposite, so if this was positive, positive, and this was negative, same answer. It just means you chose to move things differently than I did. Okay? All right, let's try another one. All right, so we want to find all relative extrema. Remember, that just means where are all of our relative maximums and minimums. For this equation right here, y equals 2x minus the natural log of 2x. When we do this, when we're finding relative extrema, to decide whether you have a maximum or minimum, there's really two ways to do it. One is you just do the first derivative test, which we should all feel comfortable with that. The second thing is you do the first derivative, find out where things are set equal to 0, your critical numbers, and then take the second derivative to decide if it's concave down or concave up. Either way is fine. All right? You guys go ahead and try it. Alright, so if I'm going to take the derivative, I'm going to get 2 minus, I have to do u prime over u. So that means 2x, the derivative of that is 2. And then if I cancel the 2's, what I get is 2 minus 1 over x. So I need to set that equal to 0 now and solve to see where my maximums or minimums could occur. So let's see, 2 minus 1 over x equals 0. So to solve this, there's a couple different things you could do. You could multiply everything by the least common denominator if you want, like we did in the last problem. You could just say, let's move this over here and make it positive, and then I'll have to bring the x back over and multiply. So I think I'm going to go that way. Bring the x back over, you get 2x equals 1, and then divide by 2, you get x equals 1/2. So if there's a maximum or minimum, that's where it has to occur. And, if you want to do the second derivative, that's fine. Check to see whether it's concave up or concave down. If people feel really comfortable with the first derivative test, and you want to make intervals, so it'll be from negative infinity to 1/2, and then from 1/2 to positive infinity. You can do it this way as well. So a test number, sign, and a conclusion. Remember, if we do it this way, we're not taking any additional shortcuts. We're going to work our way through the whole thing, write everything down. So let's see, a good number to choose here would be 0. A good number to choose here would be 1. If I plug it back into the first derivative, I forgot one thing. Remember, your critical numbers are where your function equals 0 and where it's undefined. So I missed a critical number here, right? I should have had 0 in there as well. So let me fix this. This really should have gone from negative infinity to 0. And then this one should have gone from 0 to 1/2. And then this one should have gone from 1/2 to infinity. Alright, so I got to change my test numbers. Here I'm going to test -1. Here I'll test 0.1. And here I'll test 1. Alright, so now if I plug this back into the first derivative, right, this is an equivalent version to this right here. If I put a -1 in, -1 divided by -1 is a positive 1. 2 plus 1, that's 3, so I got a positive result. If I put a 0.1 in there, that's like 1/10, right? So 1 divided by 1/10, I got to flip it over and multiply. That's going to equal 10. So 2 minus 10, that's negative. And then if I put a 1 in here, I would have 1 over 1, that's 1. 2 minus 1, that's positive. So we are increasing, and then decreasing, and then increasing. So at 0, we're undefined, right? If I go back and look at the original function, if I plug in a 0 here, you can't do the natural log of 0, so this function would be undefined at that point. Okay? And then here we're decreasing, then increasing, so that would be a relative minimum at 1/2 comma something. So we have a minimum at 1/2 comma, and now I need to go back and plug that into the original function and see what I get for an answer. Oops. So if I go back to this, y at 1/2 is equal to, if I put a 1/2 there, I get 2 times a half, that's 1. If I put a 1/2 here, I would get half of, or 2 times a half, that's 1. So minus the natural log of 1. Remember, this is log base e, so e raised to what power equals 1? 0, right? Anything to the 0 power equals 1. So this is really 1 minus 0, which equals 1. So there's that coordinate, 1/2, 1. So we have a relative minimum at 1/2, 1. And remember, even though this is increasing then decreasing, there is no relative maximum there because the original function is undefined at 0. Alright, let's try another one. Alright, so we learned something new, which means find the equation of a tangent line. So using this function, we want to find the equation of the tangent line at 2, 1. Alright, you guys go ahead and try it. Alright, so first thing I need to know is, I've got a point here. I need to know what the slope of that tangent line is. And we get that through the derivative, right? So I need to find y prime. So the derivative of e to the u is e to the u, so x squared minus 2x, times the derivative of the exponent, which would be 2x minus 2. So now I want to plug a 2 into there. So y prime at 2 is going to be e raised to the 2 squared, that's 4, minus 2 times 2, that's 4, times 2 times 2, that's 4, minus 2. And so what I get is e to the 0 power times 2. Anything to the 0 is 1, so 1 times 2, that is 2. There's my slope for that tangent line. And so now I can go back and use this point right here along with that slope and write the equation of a line. Y minus the y value equals the slope times x minus the x value. So if we distribute that, y minus 1 equals 2x minus 4. Add 1 to both sides, we get y equals 2x minus 3. There's our tangent line. Alright, one last problem. Alright, so let's see, last question. So we've got 1 plus the natural log of xy, should have that in parentheses, equals e raised to the x minus y. And they want us to find the derivative. You know, so again, I look at that, and if I had to get y by itself, I mean, I've got some ideas, but I've never done anything like this before, so I'm not sure I could do it. All right, so I would definitely want to take the derivative implicitly. All right, you guys go ahead and try it. So derivative of 1 is 0. Derivative of a natural log, that's u prime over u. So here's the u part. If I take the derivative, it's kind of like the one we did before. I'm multiplying these two things, so I have to use the product rule. So I'll do derivative first, which is 1 times y. And I just took the derivative of an x variable. Plus, leave the first part the way it is. Take the derivative of that, which is 1. And I just took the derivative of y. And that equals e to the u prime. So e to the x minus y times derivative of the exponent. Well, derivative that's 1, and I just took the derivative of x. Derivative that's 1, and I just took the derivative of y. Alright, so now what I need to do is I need to work at this so that every single term has either a dy or a dx with it. Right? Get rid of fractions, you know, do whatever you can, but make sure each term has either a dx or a dy with it. So I'm going to start by saying, same as the last problem, let's multiply by xy to get rid of the fraction. And so I got to do the same thing over here. I got to multiply by xy. Give me a dot. There we go. All right, so these cancel. And so I now have y times dx plus x times dy. Here I've got xy e to the x minus y. And so what I'm going to do is I'm going to take this whole thing and distribute it to each of these. That's how we get each term to have either a dx or a dy. So this is going to equal xy e to the x minus y dx minus, and now I'm multiplying this times that term. So I get xy e to the x minus y times dy. So now I have 4 terms. Every one of them has either a dx or a dy with it. And so now I just need to get all the dy's on one side, dx's on the other. Think if I take this dy term over here, I'll end up keeping more terms positive than negative. So I'm going to go that route. I'm going to leave this term here. I'm actually going to do this in 2 steps just so we don't lose anything. I'm going to move this to the other side so it becomes positive. xy e to the x minus y dy. And that equals xy e to the x minus y dx. I got to move this dx term to the other side so it becomes negative. So minus y dx. All right, factor out the dy's. I get x plus xy e to the x minus y. Factor out the dx's. I get xy e to the x minus y minus y. And now I want dy over dx, so I'll bring this over to this side. Means I got to take this over to this side and divide. So I've got xy e to the x minus y over x plus xy e to the x minus y, and that's it. Okay? Can these right here cancel? No, because it's part of something that's being added or subtracted with something else. Right? We can only cancel things that are being multiplied. Even though the x and the y are being multiplied times this, it's part of something that's being added or subtracted with something else. So that's it. I'm done right there. Kind of a weird looking expression, but that's okay. All right, that's what we have for today. Let me get you guys a homework assignment. All right, so still on week 17, this is our Thursday piece. And because we learned about natural logs and e to the u in 2 different sections, that's why we have 2 different pages here. So on page 322, we're going to do 70, 81, 83, 87, and 89. On page 348, we're going to do 57, 63, and 67. Also, make sure you check the email. The video I put out yesterday on Wednesday, I had the wrong page and problem numbers because I was looking in the old book. I just kind of spaced out and forgot. So I did send out an email trying to make a correction on those pages. All right? And problem numbers. All right, that's it. That's all we have. You guys have a good weekend. Starting Monday, start reviewing for that final exam. I know you guys are all looking forward to it. All right, take care. Stay safe. We'll see you.